Have we let everyone in yet? You're muted.
I just asked Caitlin that. All right. Hello, everyone. I think we still have people joining us, but I'm going to go ahead and get started in honor of everyone's time this afternoon. Thank you so much for joining us. My name is Heather Perez, and I am Project Director for the BJA Crime Analyst in Residence program. Welcome to the Crime Analyst in Residence program webinar, an introduction to Power BI data modeling, presented by our exceptional subject matter expert, Charlie Gabberty. Throughout today's session, we will encourage you to engage, take notes, and share your thoughts. If you have any questions, please enter them in the Q&A or chat. Charlie will answer them at the end of our session today or in follow-up communications. This webinar is being recorded and will be available on our website, crimeanalystinresidence.com. You will also be able to review our June webinar, Accelerate Your CompStat, which was presented by Amanda Bruner. You'll just need to navigate to the resources tab, and then you will find the webinars. At the conclusion of the webinar, you'll receive a short evaluation form to complete, as your feedback is incredibly valuable to us. We truly appreciate your input. We're excited to continue offering these learning opportunities and are already looking forward to our next webinar in August. Stay tuned for more details. In the sake of time, I am not going to go through Charlie's lengthy and very impressive bio, but you can find it at the end of his presentation slides. So thank you again for joining us today. Let's get started. And Charlie, I'll turn it over to you.
Thank you, everyone. Thank you, Heather. So we do have a lot of content to cover today. This is a really big challenge to give you enough knowledge of modeling to be able to go do something on your own and do it in just 1 hour. So I'm going to go ahead and jump right in. There's a link in the chat that should take you to a Google Drive, and you can download a zip file. When you download that zip file and open it up, it should look a little bit like this. I do want to warn you that you can actually navigate into the zip file without actually unzipping it, but that might cause you problems later when you try to use some of that data. So make sure that you unzip it. I do also want to give a disclaimer to some of you that there is a currently identified bug in Power BI that affects some newer processors in computers, and specifically their ability to handle dates. So whenever you open up your dashboard, if you start seeing that some of these visualizations aren't there, that may be because you've been affected by that bug. Sorry about it. Just learned about this a week or two ago, so I didn't really have time to send out the warning or whatever. But whenever you open that file up, you should see a couple of different things. There is a Power BI dashboard that's already made there called IACA 2024. I put this together for a training symposium we did for IACA in Las Vegas last year. And specifically, I wanted to focus on these first two dashboards. So we kind of assume at the beginning of this class that if you're here, you probably have some familiarity with Power BI already. You know how to work with one set of data and make some visualizations like cards and maps and slicers and line graphs and bar graphs and things like that. When we train analysts, we train them to make a dashboard that looks very much like this one because it's a good sampling of all of the different visualizations. We call this a beginner dashboard, and this one over here, that's offenses plus CAD, and the one that's called offender workup are our intermediate and advanced dashboards. Now, you might look at these three and kind of wonder why it is this one is a beginner and this one is intermediate and this one is advanced, because the visualizations certainly look a little more simple on some of these other dashboards. And the reason is because this first dashboard here, that's just called offenses, only runs off of one table of data. So you can drag and drop in Excel into Power BI and build this dashboard. Everything in here looks at offenses and breaks them down by where they occurred, when they occurred, who the reporting officer was, how many there were, how many of them were part one. But every visualization in here has to do with offense level data. When you come over to the offenses plus CAD dashboard, we now see two different types of data. Over on the left, we have offenses being counted by these cards in a top 10 offense breakdown in a bar chart. And on the right, we have calls for service. So this is two different tables. And you'll notice that whenever I adjust this date slicer, all of those tables are filtered. In order to make a dashboard that can cohesively filter more than one table of data, you have to build a data model. And whenever we do Power BI training, typically we've got a really engaged room while we build this first dashboard. Everyone loves how easy it is to put together a card or put together a matrix and a map. You're just dragging and dropping and it's fairly intuitive. But whenever we get to modeling, this is where we tend to lose people. It's where people tend to get a little ambiguous with what the rules are, because whenever you're working off of one table of data, Power BI is pretty automatic. It's really hard to produce an incorrect visual in Power BI off of one table of data. But when you start doing this off of multiple tables and actually building a model, then it is possible that you can create a bar chart that is actually giving you incorrect information. And there are a bunch of rules and it gets very technical. And so if you've never dealt with relational data before, it can be somewhat daunting. The bad news is if you have dealt with relational data before, it can look familiar enough to make you think that it's intuitive and you can apply all of the same rules that you've used when you're building like SQL queries in Microsoft Access or something like that. But in reality, it's different enough that actually, no, you can't quite do it that way. So we are going to build a bare bones version of this dashboard together. But first, I am going to review a little bit of a PowerPoint to talk about what it is we're going to do step by step. So our goal is to build one dashboard off of multiple tables of data. And we have to have slicers that can effectively filter visualizations built off both of those tables. So you can see a really stripped down version of what I'm talking about here, where we have one date slicer in the middle. And on the left, we've got a card that's counting offense data. And on the right, we've got a card that's counting calls for service data. This is modeled properly. So if you were to adjust that date range, both cards would change. The term modeling can be a little ambiguous. For those of you who came out of the academic space and you're referring to modeling, you're very often talking about hypothesis testing, measuring correlations with multivariate models, things like OLS regression, binary logistic regression, things like that. Data scientists often use the term to talk about machine learning and prediction. So for instance, on one project that I was on, we created a machine learning model that looked at every transaction that came into a bank and predicted whether or not that transaction was part of a money laundering scheme. And so in that sense, you're typically training a model on data that you've already said, you know, this is money laundering, this is not. So it can pick up on those correlations and then start applying those predictions to incoming data. None of that is what we mean when we talk about modeling in Power BI. In Power BI, we're talking about making a semantic model that is using text, symbols, and diagrams to create a visual representation of data as it's captured and stored. How a model is made will affect what filters you can use, what visuals are aggregating on your dashboard, and creating them improperly can mean that your dashboards are displaying incorrect information. What's really insidious about this is that if you make an incorrect model, it will still display information on the dashboard, it just will be incorrect. So it is really important to understand what it is you're doing. I'm going to use the metaphor of water and plumbing throughout this because it's what makes the most sense to me. I like to tell people that filters come from a water source and flow to an aggregation source. And the way that you make those, the way that you lay those pipes are how the filter will flow from one visual to another. If that doesn't make intuitive sense right away, hang with me, it will in just a minute. So this is what a standard data model looks like inside Power BI. In this case, we've got 5 different tables, and every single one of them are connected to the financials table in the center. And you'll notice that not only are these tables represented by, you know, these squares with all of the columns listed out inside of them, but the links themselves also have some symbolism going on. So you can see some ones on this side of the link, an arrow pointing this way, and then a sort of starburst on the financial side of this link. What this indicates is that this is a one-to-many connection. That's what the one and the starburst mean. And that the filtering direction is one way. What that means, this arrow pointing away from products and towards financials, what that means is that if we were to build a slicer on the products table and a bar graph on the financials table, that slicer can filter that bar graph. The water can flow from products into financials. But the other way around, it won't work. We could not build a slicer on financials and filter a bar chart built on products. It doesn't flow in that direction. This is really important. A lot of analysts, when they start building this, they think, well, I want a model to be as flexible as possible, so I'm going to have things flow in both directions. I'm going to have many-to-many connections, and that's actually the exact opposite of what you want to do, and we're going to get into why here in just a second. Microsoft has a term for the pattern of modeling that we're going to be using today. It's called a star pattern. So a star pattern puts your fact tables in the center, your dimension tables on the outside, and they should be connected via one-to-many connections with one-way filtering, just like this guy. So what is a dimension table and what is a fact table? Very simply put, a fact table is what you want to aggregate. So if you want to analyze calls for service and offenses over time and patterns and trends and things like that, then those are the things that you're aggregating. You're counting them, you're looking at averages, whatever. Your dimension tables are what you want to slice on. So if you want to build a slicer that allows you to adjust a date range and see how your patterns and trends are changing, then you want to slice on a date table. If you want to be able to filter on an officer's name, the officer who filled out a report and the officer who responded to a call for service, then you need a roster of officer names. Those are your dimension tables. If you want to be able to filter by zone or precinct or beat, then you need dimension tables that list out zone or precincts or beats. There's a couple things to keep in mind about these dimension tables. First of all, they must have unique values. So in the instance of a beat table, what we need to see in that table is that every beat occurs on exactly one row. They cannot repeat. Dates, the same thing. Every date can occur exactly one time on exactly one row. They cannot repeat. This is why these connections are one-to-many. It's because on what we're connecting these tables on, the columns we're connecting these tables on, the values in those columns can only occur one time in the dimension table, but they can occur many times in the fact table. So if you think about the example of a date table, in our date table, every date can only occur on one row, but every date could have many calls for service. It could have many offense reports. And so those are all one-to-many connections. The other thing to keep in mind is that values have to match exactly. So if I am connecting a, let's just say a table of zones to a table of calls for service. In the zones table, if I've got values listed as zone 1, zone 2, zone 3, with the word spelled out, but in our calls for service table, the zone gets logged with a code, Z1, Z2, Z3. You have to account for the difference in those values. Conceptually, they are the same, and you can make a join between those tables, but you either have to change the dimension table or you have to change the fact table or both. If that's a little confusing, don't worry. We're going to work through joining 3 different tables to 2 different fact tables. All 3 of them are going to have 3 different types of joins. And so we're going to walk through a very broad range of how to make the values match exactly. So here I've got 2 tables. I've got calls for service on one side and I've got reports on the other. And so if we're looking at things that they have in common, they both have an officer field in common. And so because of that, I can create a dashboard that aggregates reports and calls for service and allows you to filter by officer name. However, you'll notice that officer name is in 2 different formats. Over on the left, calls for service just lists out a last name. And over on the right, it's a last name with a first initial. So we're going to have to do a little bit of data cleanup, or we're going to have to create a filter table that account for that difference. And again, we'll walk through examples of how to do that. We might also join them together on date. But again, you'll notice that on the left side, we've got just standard date, and on the right side, we've got date time. Generally speaking, the date time field does enable you to do some really cool things. Like in the demo dashboards that I've given you, there's a day of week, hour of day heat map, and you have to have time in order to do that. Speaking generally though, date time fields are a real pain when it comes to modeling data. And so typically what I recommend everyone does is create a new column that just strips out the time and then use that for modeling. And again, we'll work through an example of that. So if we're looking at these two tables inside Power BI, you've got offense data on the left, CAD on the right. You might think that the thing to do is to, okay, both of them have a date field, so I'm just going to draw a line and connect the two tables. That is incorrect. Modeling rule number one, start by thinking about what you want to slice on, what you want to filter on, because you're going to have to create tables of unique values for those dimensions. So start with a table of distinct values for the slicer to read, and think of filters like water flowing through plumbing. So instead of connecting offense data directly to CAD data via the date field, we're going to create a date table, and we are going to connect that via a one-to-many connection to offenses, and then we're going to connect it to via a one-to-many connection to CAD, calls for service. We want to be able to filter on three things. Like I said, we're going to set up 3 different tables, and we're going to model them into both CAD and calls for service. We want to be able to filter on a person's name, specifically an officer's name. So we want to be able to select an officer and see how many calls for service they were primary on and how many reports that they've written. We want to be able to filter by zone. So we want to be able to select a zone on the dashboard and see how many calls for services have been there and how many offense reports have been written there. And we want to be able to change a date range. So we have to come up with, there's really 2 different problems for each of these tables. First of all is, where do we get the unique tables from? And then second of all, how do we actually model them in? Some of these things you probably already have. So somewhere in your RMS, somewhere in your organization, there probably already is a roster of officers' names. Some of these things you can make on your own. So for instance, like you may not have a zone table, but chances are you probably only have less than a dozen zones or precincts or beats inside your jurisdiction. Of course, if you're somewhere like NYPD, it might be a lot more. But still, if you've got less than 100 values, you can just type them out into Excel and then bring those into Power BI. You can't do that for dates, though, because if you have to generate a unique row for every date for 10 years worth of data, that's 3,650 rows. That would just take forever, and you'd have to add a new one every day. So Power BI has some really powerful DAX functions that you can use to create tables for the purposes of modeling. And don't worry, if you've never used DAX before and you're not a very codey person, I'm a big fan of teaching people how to use ChatGPT to sort of cheat and generate those DAX statements. And so that's what we're going to do. Modeling rule number 2, build connections from your distinct value tables to the data tables you want to aggregate. We want to never use many-to-many connections. There are times where you can use a many-to-many connection and it will be accurate. The problem is ambiguous joins. So if you join 2 tables together via many-to-many connections, if you then try to add in a 3rd table, a 4th table, a 5th table, the data model gets too complicated and it doesn't know how to filter. So for instance, here's a real simple example. If we were to join 3 tables together like this, table 1 connected to table 2, table 1 connected to table 3, and table 2 connected to table 3. Let's just say that we built this data model. Power BI would not let you build this data model, by the way. And the reason it wouldn't let you do that is because imagine if we built a slicer on table 1 and a bar chart on table 3. It wouldn't know which way the filter was supposed to flow. Is it supposed to flow directly from table 1 to table 3 to filter that bar chart? Or is it supposed to filter through table 2 into table 3 to filter that bar chart? This is an ambiguous join or an ambiguous model. And the more you use many-to-many connections, the more likely you are to run into an ambiguous pathway and your model will break. So we want to minimize the use of many-to-many connections. We do that by using these unique value tables to make slicers. Filter directions can be singular or both, but where possible, you always want to use a single direction. I used to say that I've never worked in a police department and seen a one-to-one connection, but actually I just did very recently in the past couple of months. One-to-one connections are totally fine, but you're rarely going to run into them. One-to-many connections are also totally fine. All right, so let's get into, now that we've sort of covered this theoretically, let's get into actually building out a dashboard. So I'm going to open up a totally blank report inside Power BI. And we're going to start from absolute scratch. So the first thing that we're going to want to do is bring in some data. So if you go to Get Data and Excel Workbook, if you navigate over to that Power BI download file, there should be an Excel in there called RMS Offenses. I'm going to go ahead and select that. It's going to bring in the data loading screen. You've got some options at this point. We're just going to select this data tab here. This is where you could launch Power Query if you wanted to. I'm just going to go ahead and hit load. This table by default is going to be called data in our modeling view. That's just because the tab that it's saved in inside Microsoft Excel is just called data, but we can change that so that we can kind of keep ourselves straight. And it should load about 8,000 rows. If you go over to your model view, there should now be a table floating in space. If you want to change the name, you can just click on it so that it highlights the table in green, and come over here to your properties window and just change the name. So I'm going to call this offenses. Then we're going to do the same thing. I'm going to go up to Get Data. The CAD data is stored as a CSV though, so you'll want to make sure that when you click on Get Data, you go to text/CSV. And there should just be a table called CAD. It's going to do the same thing, bring up that data ingestion window. I'm going to hit load. Okay. So really quickly, I'm going to throw together a dashboard that just has two cards on it. One that counts CAD, calls for service, and one that counts offenses. So to do that, I'm going to go up to my report view. I'm going to find a card visual, which is this little square with a 1, 2, 3 on it. I'll start with CAD. I'm going to take the CAD number column and bring it into the fields pane. And I'm going to change this from a sum to a count. Now, I'm not going to put a whole lot of pains into formatting this because we do assume that you kind of already know something about building visualizations. And then I'm going to do the same thing over with offense data. I'm going to build out a card, put on the right. I'm going to bring in my offense number column, change that from a sum to a count. There we go. So we've got two different cards here, and our goal is to build a series of slicers that can filter both of them. Now, the filters, when we get done with them, it doesn't matter whether or not you're talking about a card or a bar chart or a line chart or a map. We can build any of those visuals that we wanted to off of either of these tables. If we do this correctly, our slicers should be able to filter all of those visualizations. So how do we do that? Well, I'm going to start with something really easy. The first thing that we need to do is look through both of these tables and see what fields do they have in common. So I've kind of already given this away. They both have a zone column. They both have a officer column, although the offenses table is the column is called officer, and in CAD it's called responding officer. Both of them contain the same type of information. It's just officer name. And then they also both have a date. Again, in the offenses, it's date occurred. In your actual RMS database, you probably have date occurred, date reported. Inside CAD, you probably have, date time call received, date time dispatch, date time arrived. In this case, we're just using these date columns for the purposes of keeping this kind of simple. So I'm going to start by joining together on reporting officer. So the first step in this process for me is to actually look at the raw data and see what format those fields are in. So I'm going to go over to my table view. I'm looking at CAD, and I'm looking at the responding officer column, and I'm noting that the format here is just the last name, camel case, meaning the first letter is capital and everything else is lowercase. And then if I come over here to offenses and I find the officer column, it's the same thing. These two columns are in the exact same format, which is going to make this super duper easy. Also making this super duper easy is that I've already given you a roster of names. So if you come into your zip file, there's a subfolder called Useful Excel, and you've got an Excel sheet that's got a roster of officer names in it. And so we're going to incorporate that. So I'm going to go up to Get Data, Excel Workbook, go into Useful Excel and Roster. And as you can see, this just has one column and it's just those last names. Kind of cheating to make it this easy on you, but don't worry, it will get harder. All right, so I'm going to do the same thing. I'm going to change up the name of this table just so that I can keep myself straight. So I'm going to click on sheet 1. I'm going to open up its table properties. And then I'm going to change this to officer roster. All right. And again, you can look at the data inside the officer roster table, and you can see it didn't pick up that our column header was a column header, so it thinks the first row is called officer. That's actually not going to make a difference. Every officer's last name in here is unique. If you are doing this inside your actual agency, you might want to actually go through and make sure that your officer name values are unique and that they match up with what you've got in RMS and CAD. So like if you're at a big department, you probably have multiple Officer Smiths or Officer Brown or whatever. Just keep that in mind. All right, so to join this together, I'm going to click and drag column 1 over to our officer field in offenses on the left. When I do that, it brings up the relationship window. And so what this is doing is it's saying, hey, we're making a new join between two tables. The first table is officer roster, and we're joining column 1 to the second table, which is offenses, on the officer column. Now you can change this if you want to, like if you didn't drag and drop that in like the exact perfect spot, that's fine. You can just come in here and select a new column, but that is where we want the join to occur. The cardinality on this is 1 to many, which we like.
Charlie,
Yeah.
there's somebody with their hand raised for a question.
Oh, okay. I am not seeing a question. If you've got a question, could you put it in the chat?
Charlie, I don't see it either at the moment.
Maybe
Caitlin,
it's from Lori. I just gave her permission to unmute herself if she'd like to ask a question.
Okay, cool. Thanks, Caitlin.
Yeah, by all means, if you've got a question, you can throw them in the chat. We're also going to hopefully finish up with a little bit of extra time, so we can also come back at the end if somebody wants to revisit something. So joining, making our first relationship here, we're joining the officer roster table to the offenses table on the officer field. Our cardinality is 1 to many, which, as I covered earlier, we really like to see. And the cross-filter direction is single. We're also choosing to make this relationship active. If you would create an ambiguous model by creating this join, it would not allow you to make this relationship active. And so if you're ever modeling and you're like, all right, well, I've got everything set up, but like for whatever reason, it won't let me click on this, that's the reason why. And as you can see, we've got our first link here, linking our officer roster table to our offenses table. And now we're going to do the same thing. I'm just going to link officer roster over to CAD by the same process. So I'm just going to click and drag this column, bring it over to responding officer. What this is telling me is that we are joining the officer roster table to the CAD table via the responding officer field. The cardinality is one to many, the cross filter direction is single, and it's allowing me to make it active, so I know everything is good in the hood. Okay, so at this point, what exactly have we achieved? If we go back to our dashboard, I should now see 3 different tables over here. And I'm going to build a slicer. I'm going to put it in the center. And I'm going to bring in that column 1 from the officer roster table. And so you'll know that you've done this correctly if you can come in here and select different officer names, and the counts in both of these cards are changing. And so again, I would never put anything into production that you don't verify the accuracy of a couple different ways. And once you've started modeling, you've introduced the possibility for inaccuracy. So I just want to stress that I would go through here and I would, go through the front end of your CAD and RMS, or have IT try to verify your numbers or whatever, and make sure that Officer Adams really did respond to 138 calls for service and fill out 117 offense reports or whatever. But the fact that I'm going in here and I'm interacting with this slicer and both of those are changing indicates to me that this was probably done properly. So we've got one slicer down. I'm going to make it a little bit more difficult with this next one. So we also want to be able to filter on zone, and this is where it's going to get hard. So I'm going to do the same thing. I've identified that zone occurs in both tables. And so I'm going to open these up in table view, and I'm going to look at the zone values, and we'll start with offenses. And in offenses, you can see that the zones are just a number. And you can actually click on these filters and you can see all the potential values. But if we go to CAD and you look at the zone column, these are the same zones, but the coding is different. It stores them all with a Z in front. So we've got a couple different options here. We can do the same thing that we just did. Use some sort of table on the back end. I'm actually going to make one from scratch that will work for this purpose. So I'm just going to fire up Excel. Now remember these unique value tables, every row has to be a distinct value, but every row can have multiple attributes. So you can have multiple columns, just so long as every zone only occurs on one row. So I'm going to make a table with 2 columns, one called RMS zone and the other one called CAD zone. And row 1 is going to be zone 1, but I'm going to put down the coding for both tables in this row. And then I'm going to do the same thing for all of the other zones. There we go. So there you go. If you don't just have a table that you can pull in, you can, if there's only a couple values, just go make one. And so I'm going to save this. I'll just put this on my desktop so it's nice and easy to find. And then I can bring it into my data model and I can use it to filter. So I'm going to go up to Get Data, Excel Workbook. Going to go to my desktop. There's my car zones Excel. We can see that it's showing up inside Power BI exactly the same way that I made it inside Excel. I'm going to hit load. So I'm going to bring this over here to the center. And I'm going to do the same thing that I've done before. I don't want this called sheet 1 because that's going to confuse me later whenever this gets bigger. So I'm going to change the name of this table to zone. Now, this is going to be a little bit different. Conceptually, we're doing the exact same thing we did before. I'm joining one row to many rows of the offenses in CAD table. But this time we're going to perform that join with two different columns. We're still just joining one row to many rows. So these are still just one to many connections. But we had to account for the fact that the data values are different in the CAD table and in the offenses table. So I'm going to take my RMS zone column and drag it over to zone. Here we can see I've got my RMS zone selected, and I've got my zone in the offense table selected. You can see the values are matching up. They're the same type, it's just one number. The cardinality is one to many, the cross filter direction is single, and it is active. All stuff we love to see. And now I'm going to do the same thing for CAD. I'm going to grab this CAD zone. I'm going to bring it over here to the zone field inside CAD. I can see that it's now performing this join on the CAD zone column to the zone column in the CAD table. The values are matching up. It's still a number 1 through 8, but they start with the letter Z in front of both of them. Still one to many, cross filter direction is still single, the relationship is still active. All of that is looking great. All right, let's go add it to our dashboard. So I'm going to come over here and add in one more slicer. I'm going to be sure that I use the zone field from the zone table. And it doesn't actually matter which of these columns we use. The reason it doesn't matter which of the columns that we use are because as the end user, when you're interacting with that slicer, if you build it off of RMS zone and they select one, they're also selecting this entire row. So they're also selecting Z1. So it doesn't actually practically matter which of these columns we use because all of the values correspond with the other value in the same row. So I'm going to throw in, my CAD zone to the field here. And now we've got an even more dynamic dashboard. So if we want to see how many calls for service and reports Officer Allen took inside zone 1, we can select both of these. And as we select and unselect both of them, both numbers are changing. That again is going to indicate to me that this was probably made properly. Again, with the disclaimer that you should always go and validate your dashboards. All right, so the next step is to put a date table in. If there is one thing you take away from today's class, it would be the importance of date tables. There are a ton of different functions that you can deploy using measures and DAX statements that don't really work very well unless you have a date table. If you are working off of really big data, even if you can just work off of one table, it's probably still faster to use a date table to filter that table as opposed to building a slicer off of a date field within the table itself. There are a lot of good reasons to use date tables, but again, we've got some problems to overcome. The first is that we can't just go in and fire up Microsoft Excel and type in every date. So this data runs from 2020 through the end of 2024. So that's 4 whole years worth of data. And if I was to spend all of this time that I would need to put in 1,200 plus rows of dates, that would take all the time that we have. So we can use a DAX statement to use a formula to generate this table for us. We can also have it constantly re-update that table. So if you are always pulling in 5 years worth of data, for instance, meaning that tomorrow the stuff from 7/15/2020 is going to fall off, then you don't need to always, have a finite start date. You do always need to have a dynamic end date because the day is always advancing, right? Well, we can set up a formula that will figure all of that stuff out for us. And like I said at the beginning of the class, I'm not a big fan of spending a lot of time memorizing different DAX or Excel functions. I much prefer using ChatGPT to just cheat. So if you haven't used ChatGPT before, you just go to openai.com. You can hit try ChatGPT. You don't even have to log in or create an account. If it gives you this thing right here, you can just hit stay logged out, and your interface looks very much like Google. The key to effectively using ChatGPT to write code is to be incredibly specific with what you have and what you want it to do. So I like to always start by telling it I'm working in Power BI. I need a DAX statement that will make a date table for me. The date table should have dates that run through today and start.
Charlie, we have another question.
5 years ago. Yeah.
Akshata, can you unmute yourself?
I am not hearing or seeing a question.
Akshata, I don't believe that we can hear you when you unmute. You try again.
Okay, Charlie, why don't you just go ahead and we'll try to figure out getting her question and get it answered then here in a minute.
Yeah. We can always come back at the end.
Okay, cool.
So I'm just going to tell it I'm working Power BI. I need a DAX statement that will make a date table for me. The date table should have dates that run through today and start 5 years ago. The reason that I word it like that is because I always wanted to have exactly 5 years worth of data. If I tell it I want it to start on 1/1/2020 and run through today, then it's always going to be growing by one day, and I don't necessarily want that to happen. So here we go. It's giving me this formula here. You don't necessarily have to understand what any of this means because it's going to work wonderfully for us. So I will put this in the chat for those of you who want to follow along but aren't, using ChatGPT. That's totally fine. So to deploy this, I'm going to go into my model view and I'm going to hit new table. And then I'm just going to paste that formula in and hit this green check mark. All right, so let's just look at this data real quick and see what it came up with. So if we look at our date table in the table view, you can see that every row represents one date. It's got a whole bunch of, it's got 6 different columns that all are different attributes pertaining to that date. So we've got a date time field, we've got a year month number, year month, quarter, year month combo. And this is great, except it generated a date time column. And like I said from the beginning, working with date time is a nightmare. If I were to make a model, if I were to connect that into all the offense and CAD data, it will make a connection, but the date filter won't work. And the reason that it won't work is that as you select the date, say you select 1/1/2024, it will only be selecting calls for service and offenses that occurred at exactly midnight on 1/1/2024. So we want to make this column a little bit broader. So to do that, we are going to strip out these times, and we're going to do the same thing on CAD, and we're going to do the same thing on our RMS offenses, so that we have 3 columns in these tables that will match up with each other. So I'm starting with my date table. I'm going to go up to new column. I'm going to type in date 2 equals, and that just tells it that I'm creating a new column that I want to call date 2. I'm going to type in date value with an open parentheses. I'm going to put a open square bracket, and then I'm going to put that date column in it. And then I'm going to close the parentheses. I'll put that formula in the chat. Now you'll notice that when I did that, it still makes a date time. That's okay. So I'm going to select the header here where it says date 2. And then over here in the top left where it says date time, I'm going to click that drop down menu and I'm going to change this to a date. And now it's just the date without the time. If you are like me and you're a little neurotic about everything matching up or being as simple as possible, you can also change the format to short date, which I think makes it a little bit easier to work with, but that doesn't really matter, just so long as this is a date and not a date time field. Okay, this is great, but we still don't have anything to join this on. So we have to do the same thing in our other two tables, CAD and RMS. So I'm going to start with CAD. I'm going to click on New Column. And again, I'm going to call this column Date 2. I'm going to use my date value function. I'm going to put the existing date column inside it. And I'm going to hit my green check mark to tell it to go. And then I'm going to change this from a date time to a date. And make the format short date, although the format doesn't really matter. It's just how it's displayed. And then we're going to do the same thing with offenses. So here's our date occurred column that we want to clean up. So I'm going to click on New Column. Create a column called Date 2. You use my date value function. I'm going to put the date occurred column in there. And then I'm going to change that from a date time to a date into a short date. So now all three of these tables have a date column that are in the exact same format, and they are not date time. So after all that work, we're ready to model. So I'm going to go over to my date table. I'm going to go to date 2. I'm going to drag it over to the date 2 in the offensive table. Again, it's showing us that date 2 is matching up with date 2. The formats are the same. It's one to many, cross filter direction is single, and it's active. All stuff we love to see. Going to go grab date 2 and drag it over to CAD. Same thing, see the same format, one to many, single, active. Now, because this is formula driven, essentially what this formula is doing is saying, hey, add columns and create a row for every day that is today minus 5 years through today. And so today, right now, is 7/15, but tomorrow, today is going to be 7/16. And so this is always giving us exactly 5 years worth of data. It's never any more and it's never any less. This is dynamically updating all of the time. We've got this properly modeled in. So I'm going to go back to my report view. I'm going to add one more slicer. And this time I'm going to go grab my date field from my date table. And as I begin to mess around with this slider, you can see both of those visualizations on the left and right are beginning to update. And just for the sake of making the point, again, it doesn't matter that this is a card. So for instance, if we were to build a bar chart off of our CAD stuff and just look at like the call type that occurs the most often. So I'm going to throw a call type into the y-axis and the CAD number into the x-axis. As I'm beginning to move around with this date slicer, the bar chart is moving as well. And if we wanted to see very specifically how many calls for service or offenses or offense reports Officer Adams, Allen, and Anderson took inside zone 1 from 7/15 of 2020 through 11/19 of 2023, we can very quickly make all of these visualizations filter down. So I know that that was a very quick crash course in the fundamentals. We spared absolutely no time making this dashboard attractive, but the same underlying data model is inside this dashboard as well. As you move around with the date, all of these different visualizations are updating. And so we could spend time to make these things pretty, make them attractive. But what really matters are the mechanics that underlie these dashboards. That is where the biggest mistakes tend to get made. If you want to see a slightly more advanced example that we don't have time to work through in this class, there is a offender workup dashboard. This is more of an intelligence product. So this allows you to select an individual's name, and it creates a map of where you've had contact with them. It also gives you counts of how many offenses they've been involved in, how many times they've been a victim or an arrestee, known associates, people that were also in the same reports, and lists out all of their narratives as well. All of this relies on this data model underneath. So we went through a majority of building out the core of this, but if you would like an example of how to continue building this, there it is. You're more than welcome to plagiarize that and take that back to your agency. Additionally, I do have a Power BI Udemy course that does go through some modeling, but if you are looking at all of this and you're like, wow, this is really cool, but it kind of blew past me because I don't understand the basics, please reach out to me. I'm more than happy to shoot you a link to that class, and we'll walk through the very beginnings of making a dashboard, how to integrate data, how to make the most common visualizations, and how to make them pretty, and then move into a little bit more advanced topics like data modeling. So I do want to take a few minutes and answer any questions that might have popped up. Caitlin, do we have any? Oh, hey, there's a little Q&A section here. So a couple of questions have come up. Is there any reason why the shortening of the date couldn't be done in the original date column without creating new date columns? You can do it that way, but if you do it that way, then you don't have a column with the time in it. And so whereas we didn't necessarily get to why time is important, one of the more common things that crime analysts like to create are day of week, hour of day heat maps. So this visualization right here, and this requires you have time inside your offense. So I like to keep it as is with the time in there and just make a copy and edit that so that I'm not losing that granularity because I might want to use it later. Lisa asked, I'm having an Excel file I need to continuously add rows to. I'm having trouble figuring out how to add it into my existing dashboard without having to redo everything. Oh, Caitlin said she would like to answer that question, so I'll yield the floor.
Nope, I was just clicking that we were answering it, sorry.
Oh, okay. So this is actually a really cool question. If you link in, let's just say we made this zone table together, right? So if I were to go in and make a change to that, where did I put it? On my desktop, there it is. Let's just say, man, I need to put in zone 9 and add a new row. I can come in here and make that change, save this, and close it, and then hit refresh, and it should bring in my changes. The key to this is you can't be moving the Excel file around, so it's going to look for that exact same Excel file in the exact same place. Also, a lot of times, if you change columns, that can also cause problems. So if I go over my zone table now, you can now see that zone 9 is inside this table. So long as you're making edits to your Excel file and you're not changing the structure, the columns, or the file names, or where it's saved or anything like that, you should be able to make those changes in Excel and then just come into Power BI and hit your refresh button. I will absolutely post a link to the Udemy class in the chat. I might have one. There it is. It's here. How do I get to my chat? There you go. And it should take you to this Udemy page. Power BI for crime. How easy it is to update and change something like the officer roster? Officers are coming and going, and some get married and change their last names. So a lot of departments, there's a table on the back end of your RMS that somebody somewhere is in charge of updating. And so if you've got that, you can just connect to it. If you set up an ODBC connection from your computer, if you go to get data and more, and type in ODBC, there's your ODBC connection, and then you can just connect into the backend tables directly. Not every analyst has that type of access. And so, yeah, it does come down to, you might have to maintain your own Excel file. You can also, and we don't have time for me to show this, but if you go into ChatGPT, you can tell it, hey, pull out make a new table that is nothing but unique values from this responding officer column and this report or officer column over here on offenses. And then make sure that they're distinct values, and then you can use that. And so it's sort of the lazy man's way to do it. And you have to make sure that the table it's generating is proper and that it's actually deduplicated and that it's bringing in enough information for you to deal with the fact that some officers have very similar names. How to deal with multiple similar names. Typically, the way that this gets done is with badge numbers. So if you have a really big agency, most officers only have one badge number. This can be really complicated if badge numbers change. So they might have radio numbers or some other type of identifier that doesn't change. I would look for that. And then you can basically use that for your connections for the most part. I just tend to use officer names here because it's a little bit more universal and a little bit more intuitive. What is the benefit of only looking at 5 years without it adding a day? Typically, when I look at 5 years, I'm looking at the prior years as a whole, as well as year to date. Does PowerBI run out of room? Everything can run out of room. And for the most part, it may not matter. That being said, I always try to, for analysts who are dealing with truly big data, so like everyone kind of thinks they have big data. If you've got hundreds of millions of rows, then stuff like this might matter. For most of us, it probably doesn't. And then with officers' names, how can you account if their name changes? Again, I would be looking for a unique identifier like a badge number or a radio number, a unit number on a vehicle, something like that. And then Misty Garcia asked for a link to the chat. I just sent it in the chat. Can you guys see that? Because I think maybe I'm only sending chats to the host and the panelists.
Charlie, it will be obviously in your slides and when the webinar gets posted. Also, we should have everyone's email addresses because they registered, and we can send it out that way too.
Okay. Yeah, so we'll make sure that we get that information. If you really like it, please give it a 5-star review. If you don't like it, please don't review it at all. I'm looking at it right now and I see that the average is 4.8 and that really pisses me off. But it's all right. I'm going to be hunting those people down. So sorry for the issues with the chat and stuff not going through, but I'll make sure that that stuff gets sent out to you.
Yes, we will definitely get that taken care of. No problem. So Charlie, I just want to say thank you so much. This was an excellent presentation. I really appreciate the pace of learning that you provided today. I know the car sites have greatly benefited from your expertise. So we appreciate you, and thank you to everyone for joining us today. We hope you find the session helpful and inspiring. And yep, do those evaluations, please. They will be sent out momentarily. Again, we will have a webinar in August. How can analysts be involved in community engagement? One of our subject matter experts and one of our car embedded analysts will be offering that, which will be a really awesome one as well. So thank you guys again for joining, and look forward to you all joining us again in August. Thank you, everyone.
Thank you all.